Alright, let's sketch the following function with attention to domain range, asymptotes, intercepts, and behavior. And here we have f of x is equal to 1 over x minus 3 minus 1. So this is actually a reciprocal function, right? Specifically, this is the reciprocal of a linear function. You can notice here that on the denominator, we basically have a linear function in the form of y is equal to mx plus b, right? Well, technically it's an expression, right? So it's going to look like mx plus b, and you can notice that x is to a power of 1, right? So it is basically a reciprocal of a linear function, and we're going to call this a linear reciprocal function. Okay, so let's say we wanted to analyze this function. So let's start with the domain and range. So if we're starting with the domain and range here, for the domain, x can belong to the set of all real numbers. However, there is a single restriction that x cannot be equal to, and we can understand that if we have f of 3 here, then 1 over 3 minus 3 minus 1 is going to give us 1 over 0 minus 1, and 1 over 0 doesn't exist, right? So because this doesn't exist, we say x cannot equal 3. Okay, so that's the restriction on the domain. If we're looking at the range here, if we take a look at this function, well, this portion of the function, the 1 over x minus 3, we can notice that this is a fraction, and we know that fractions can only equal 0 when the numerator is equal to 0. However, in this case, for the reciprocal function, the numerator will never become 0 because it's a constant 1, right? So we can notice that this cannot equal 0. So because this fraction, this portion here cannot equal 0, 0 minus 1 doesn't happen. So we can say that y belongs to the set of all real numbers, but y cannot equal -1, right? So if you're looking at a reciprocal of a linear function, you can always note that the y-intercept here, the -1 here, will be the value of the restriction on the y, right? Now, the next thing we want to do here is we want to look at asymptotes. So if we're looking at asymptotes, the restriction on the domain represents the vertical asymptote. So the vertical asymptote, and we know that asymptotes are basically points that don't actually exist on the graph, but the graph will basically extend towards infinity or a certain value, closer and closer to that point, right? So vertical asymptote is the restriction on the domain. So the vertical asymptote in this case is x is equal to 3. The horizontal asymptote in this case is the restriction on the range, which is basically y is equal to -1. So that's what you want to try to understand. And once you have these asymptotes, what you can do here is you can actually graph this on a certain grid, right? So if we're going to graph this, I'm just going to kind of create a sketch here, because I want to sketch this function at the end of the day. I'm going to try to sketch this here. Okay, so this is my graph, and I'm going to make the vertical asymptote in red, x is equal to 3. So let's say this is my vertical asymptote here. Okay, so this is my vertical asymptote, x is equal to 3. Right, I'm going to make each of these giant squares go up by 1. And my horizontal asymptote, I'm going to do this in green, my horizontal asymptote is y is equal to -1. So this is my horizontal asymptote, y is equal to -1. So these asymptotes act as essentially a boundary or a barrier, and it prevents the graph from crossing these points. Now, the next thing you want to do here is you also want to find the intercepts. So I'm going to take a look at part C here. So I'm looking at my intercepts. You want to look at your x-intercept and your y-intercept. So I'm going to start off by finding my x-intercept. Okay, so we know that the x-intercept exists when the y value is 0. So I'm going to let f of x equal 0. So if I let f of x equal 0, I get 1 over x minus 3 minus 1 is equal to 0. I'm going to move the 1 to the other side. You get 1 over x minus 3 is equal to 1. And what I'm going to do is I'm going to do the reciprocal. You can also cross multiply, it's the same notion. And you basically get x minus 3 is equal to 1. I'm going to move the 3 to the other side. X is equal to 4. So because y is equal to 0 and x is equal to 4, the point here is 4 and 0. So that's my x-intercept. So my x-intercept in this case, let's say it's like somewhere here. Okay, so I'm just going to keep using this grid system. So this is the point 4 and 0. So using my point 4 and 0, I have to use the confines of the asymptote. So if I'm using the confines of the asymptote, what I'm going to do here is I'm going to sketch my graph in orange. And if using the confines of the asymptote, I can notice that this is my grid system. Remember that this is once again a sketch. If you want exact points, you could use some test points, you can plot it in, but we just want to get the idea across. Now we also want to find the y-intercept. So if I want to find my y-intercept here, what I want to do here is I'm going to let x equal 0. If I let x equal 0, I'm going to do f of 0, which is equal to 1 over 0 minus 3 minus 1, which is basically negative 1 over 3 minus 1, which is basically negative 4 over 3, right? Because 1 is basically 3 over 3. So I have the point 0 and negative 4 over 3. That's my y-intercept. Okay, and 0 and negative 4 over 3. This is approximately negative 1.0 and negative 1.333. Right, let's keep going. So let's say that that point here is located, right, it's a slightly lower than 1. So let's say it's somewhere here. Okay, so this is 0 and negative 1.33. Or if we want to use the exact value, we can do 0 and negative 4 over 3. Okay, so and then we can use these asymptotes to act as boundaries. So this is your graph. It's going to follow the asymptote, and we can actually determine what the asymptote really is by looking at the end behavior of the graph, which I'm going to show you in this next step. So the end behavior is what direction does y head when x approaches either positive or negative infinity or the asymptotes. Well, let's say x is approaching, okay, this is negative infinity for x, this is positive infinity for x, this is positive infinity for y, and this is negative infinity for y. So let's say that x approaches negative infinity. Okay, and if you guys do take calculus, you'll also find another way of expressing this, but for the time being we'll just use arrows to represent approaches. So as x approaches negative infinity, as I go this way on the graph, what's going to happen to y here, if you follow the trace in orange, the graph, or the y values actually approach the asymptote y is equal to negative 1, and they get closer and closer. And you can also notice that y approaches negative 1 from below the asymptote. So to show that it's below the asymptote, we usually put a little negative sign. You can also write down below if you want. The other case that you want to look at is this vertical asymptote. Let's say we approach this vertical asymptote. Now you can approach the vertical asymptote from the left side, or you can approach the vertical asymptote from the right side. Now if I'm approaching the vertical asymptote from the left side, you can write this as the vertical asymptote being 3. You can write this as 3 negative. This is approaching it from the left side, or 3 left. And 3 negative just means that it's a value that's really close to 3 that's approaching it from the left side. This could be like 2.99. Approaching it from the right side, we can express this as 3 positive. So a value that is very close to the right of 3 is like 3.001. So as x approaches 3 from the left side, if it's a value like 2.99, it gets closer and closer to 3 in small increments. We can notice that the graph here in orange, it basically will approach negative infinity. Okay. Now as x approaches 3 from the right side, so I'm going this way to 3, you can see that the trace here gets closer and closer to 3, but it'll go all the way to positive infinity. So y actually approaches positive infinity. So these are what we call end behavior. Right? You can see that there, and you can see that using the arrows. Right? And usually around an asymptote, y will always kind of approach infinity. So if you approach a vertical asymptote, you're going to approach infinity. But as x approaches positive or negative infinity, y will approach a horizontal asymptote. So this is very important to understand. And as x approaches positive infinity, so as I go this way to the right of the x values, you can see that the asymptote of the graph here is going to approach the horizontal asymptote. Y is approaching negative 1, but this time up top from above, right? So we just write negative 1 plus. And yeah, that's our sketch for our reciprocal function.